Force and energy connection. So the connection between force and energy is work. Remember that work is the change in energy of an object or a system. So in a closed system, there's no net force, there's no work done on it, so energy is conserved. All right, but we did look at work done on a system. It was equal to change in energy. But remember, we left out part of what's on the equation sheet. So for the whole enchilada, all right, work equals the change in energy, but it also equals the force parallel times the distance, all right, equals FD cosine theta. Okay. So what this means is that the force has to act in the same direction as the distance traveled. So when we were putting the weight on the spring, okay, the weight did work on the spring to stretch it out, and that was parallel just the direction that it stretched, okay? So that's what that's talking about. We'll talk about some specific cases later on. So if there is an angle between the force and this distance, that's where the cosine comes in. And we'll see another example of that later as well. Okay, so one of the easiest examples is if I am pulling a wagon, the handle's not horizontal, it's at an angle. So the force I'm applying, all right, is not actually opposing the motion. So it's not in the same direction as the distance traveled. That will be important with friction, and we'll see that one later on.